Hello and welcome to your stats warm-up. All right, so let's see what we have here. Number one, explain the difference between saying two events are mutually exclusive and two events are independent. So make sure that you know the difference between these two terms. So mutually exclusive. When one event has occurred, the other event cannot occur. All right, so if one is happening, the other is automatically not happening. All right, they can never happen at the same time. They can never happen together. They are mutually exclusive. When two events are independent, when one event happens, it has no impact on the probability the other event will happen. All right, so two very different things. This is saying if one event happens, the other one can't occur. They never happen at the same time. This one is saying knowing that one happened has no impact on the odds that the other one will happen. So just make sure you keep that difference in your head because they are two very different concepts. Number two, are the events participating in extracurriculars and high honor roll independent? Justify your answer with the appropriate calculations. All right, so there are two ways we can do this. We either have to show that the probability of high honor roll is the same as the probability of high honor roll given you participate in extracurriculars, or doesn't matter which one we do, it's just one or the other. We have to show that the probability of extracurriculars is the same as the probability of extracurriculars given you're on high honor roll. All right. So I'm going to do both of them just so you can see it, but you only ever have to do one because they're going to reach the same conclusion. So the probability of high honor roll, there are 80 students on high honor roll. There are 240 in total, is 80 out of 240. And what we're asking is that the same as the probability of high honor roll given you participate in extracurriculars? Well, if you participate in extracurriculars, we're limiting ourselves to this row, which would be 55 high honor roll students out of the 165 that participate in extracurriculars. Now, you should be able to see pretty clearly that these are both going to reduce to 1/3, which shows us that they're equal, which means that they are independent. All right. Knowing that a student participates in extracurriculars does not change the probability that they're on high honor roll. It's 1/3 regardless. Now, this is going to give us the same conclusion, but I'm going to run through it anyways. So the probability of extracurriculars, 165 out of the 240 in total. And we're questioning whether or not that equals the same as the probability of being in extracurriculars given you're on high honor roll. So now we're limiting ourselves to this column, and we're saying, okay, 55 out of 80 high honor roll students also participate in extracurriculars. Now, this one might not be as clear, but if we actually do it on the calculator, 0.6875, 55 divided by 80, 6.6875. So again, these both check out. They're the same, which is what we were expecting. All right. If one of these checks out and stays consistent, the other one's going to check out and stay consistent. So what we can say here is they are independent. Because the marginal and conditional probabilities are equal. All right. Now, the next three questions are just calculating more probabilities using this table and making sure you know how to read things off this table. So this is saying find the probability of being on no honor rolls given you don't participate in extracurriculars. So if we're saying that you're not participating in extracurriculars, that's this row here, right? There's 75 people that don't participate in extracurriculars, and 30 of them are not on high honor roll. So this would go to 30 out of 75, which if we're going to write it as a percent, is just 0.4. Right. Number 4, what's the probability of selecting a student who is on high honor roll? All right, this would just be a marginal probability. So it would just be the 60 over the 240. All right, when it's a marginal probability, we're using the table total. So this would just be 60 out of 240, which reduces to 1/4, which means it's 0.25 as a decimal. Last one here. What's the probability of randomly selecting a student on high honor roll or selecting one that doesn't participate in extracurriculars? All right. So with the or, we're saying, okay, they're on high honor roll, which is right here, or they don't participate in extracurriculars, which is this row down here. Now notice that the 25 is being circled twice, right? That's sort of the overlap, and we want to make sure we don't double count it. So it's the 55 plus the 25, we're only going to count it once, plus the 20 plus the 30. So this is going to be 130 over 240. And again, if we do that really quick, 130 divided by 240, we'll say 0.5417. All right. So again, the or means it can be one or the other. And then we just have to make sure that we don't double count that one piece there. All right. So again, knowing how to read a two-way table, knowing how to prove whether things are independent, and then calculating various probabilities from that. Number 6, 27% of all students in a local high school sign up for a programming elective before graduating. 34% of all students in that same school sign up for a technology elective before graduating. 9% of students from that school sign up for both a technology and a programming course. What percent of students sign up for a programming course or a technology course? All right, so this is that same double counting issue from before. And the general rule here is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All right. This is so we don't double count. All right. We subtract away A and B so that we don't double count. So in our case, it would be the 27% plus the 34% minus the 9% so that we're not double counting those people at the end. All right. So 0.27 plus 0.34 minus 0.09, and you end up with 52%. Okay, so again, just knowing this rule, knowing how to work with ORs, and recognizing that you want to make sure you're not double counting anything there. All right, because that 9% is included in here, and it's included in here. So if we were to just add these together, we'd be counting this part twice. So we add these together and then subtract it away so that we're only counting it once. Number 7, in a recent month, 88% of automobile drivers filled their gas vehicles with regular gas, 2% purchased mid, 10% bought premium. Of those who bought regular, 28% paid with a credit card. Of those that bought mid and premium, 34 and 42% respectively paid with a credit card. Suppose we select a customer at random, draw a tree diagram to represent the situation. What's the probability the customer paid with a credit card? All right, so our tree diagram is going to have people that bought regular gas. It's going to have people that bought mid gas or mid grade. And it's going to have people that bought premium gas. Right? Of those people that bought regular gas, some are paying with a credit card and some are paying with cash. Of those that bought mid-grade gas, again, some are paying with a credit card, some are paying with cash. Same thing for premium. Right? Some are paying with a credit card, some are paying with cash. Now, we get the probabilities from the problem. So this is 88%, this is 2%, this is 10%. Of those that bought regular gas, 28% used a credit card, which means that 72% must have paid in cash. Of those that bought mid-grade gas, 34% paid with a credit card, which means that 66% must have paid in cash. And then finally for premium, 42% paid with a credit card, which must mean that 58% paid in cash. All right, so that's the tree diagram that outlines our situation. Notice that at each decision point, we're adding up to 100. So 88 plus 2 plus 10 is 100%. 28 plus 72, 100%. 34, 66, 100%. 42 plus 58, 100%. Now, if we want to know the likelihood of either of these branches, we just multiply those probabilities together. So the total probability for this branch would be 88 times 0.28. For this branch, 88 times 72. For this branch, 2% times 34, 2% times 66, 10% times 42, 10% times 58. All right. Now, this only asks for those that paid with a credit card. So we're basically looking at this branch, and this branch. Those are the 3 times that people played with the credit card. So if we want to know the total probability, it's going to be the 0.88 times 0.28 plus 0.02 times 0.34 plus 0.10 times 0.42. All right, and then it's just a matter of doing that on your calculator. So 88 times 0.28 is 2.464. 0.02 times 0.34 is just going to be 0.0068. Didn't really need my calculator for that one. And then the same thing here, 0.10 times 0.42. Again, don't really need the calculator on that one. It's just going to be 0.042. All right, so those are the individual probabilities. And then if we sum all those together, 0.2464 plus 0.0068 plus 0.042, we get a total probability of 0.2952. All right, so that's the probability of paying with a credit card is 0.2952. All right, but 1, making sure you know how to make a tree diagram, and then 2, making sure you know how to pull information from it and calculate values using it. All right, which brings us to the last question here. Given that a customer paid with a credit card, find the probability that they bought premium gas. So that's the probability of premium given that they paid with a credit card. which means we have to use our conditional probability formula, which states that it's the probability of a credit card, right? The given becomes the bottom of your fraction over the probability of premium and a credit card, right? And again, that's and. All right. Now, we actually have all of those values already up here. All right. The probability of paying with a credit card, we already found. All right. So that's the 0.2952. The probability of premium and credit is this branch right here, which means it's this multiplication. So we know that it's the 0.042. And then we just have to divide those two numbers to get our final answer. All right, so 0.042 divided by 0.2952 is 1423, we'll say. So equals 0.1423. So again, the probability that somebody bought premium gas, given they paid with credit, is this 0.1423. All right. So hopefully this was helpful. If you have any questions, just make sure you reach out. All right. Have a great day.